Good morning. Today I will present my study on Walmart weekly sales forecasting. I will explain the problem, the method, the result, and final conclusion. First, a quick summary of the whole study. This study predicts weekly sales and store department week level. I used three types of data: historical sales, storing information, like type and size, and external factors, holidays, markdown, futures, and economic indicators such as CPI and employment. The most important choice is evaluation. I use work forward validation, time series split. That means I try on early weeks and test on later weeks. On campaign to setting baseline features and feature with selected features. Main finding: feature regression is the most stable model, and feature with readers fit. For setting to 7 well capping range, performance strong. Why is this a fronting? It's important and difficult. Weekly sales focusing matters because it of course inventory decision. If we predict too low, we may have storehouse. If we predict too high, we may have actually even and markdown loss. The task is difficult because sales change with seasonality, holidays, promotion, store promotions, and economy. Also, a big risk is data leakage. If we use a random split, the model can learn from the future and performance looks better than it really is. So the question is, which model says reliable when time moves forward based on the problem? I say three objectives. My objectives are build a forecasting pipeline with no leakage, campaign baseline with futures weight in the 5-way. Find a model that is not only accurate, but also stable across time. Next, I explain the data and the modeling unit. The target is weekly sales for each store and department each week. I match sales data with store attribute and feature variables, including holiday flights, markdown variables, and macro indicators. This create one modeling table for training and testing, and it matches real retail forecasting. Next, I am pleased. What features I build? I build features in 4 groups, like features, sales from previous weeks, rolling futures, rolling mean, and rolling standard deviation, holidays, and promotion futures, holiday flights, and make down, measure store and economy features, store type size, CPI, unemployment, and under the case release, online and rolling. Futures use only past values, so the models does not use future information. Now I introduce the Q method, work forward, validation, and how I prevent leakage. This slide is the most important. I used work forward, validation, time series split. Each fold treats on earlier weeks based on later weeks. These are closer to real forecasting than random split to make the comparison fair. Bases and future weeks use same force, same metrics, and same template. Also, future selection can leak information if it sees the whole dataset. So I do future with inside each fold, fit feature with Only on the train data of the food applied the selected features to the test data of that food. This keeps evaluation clean and realistic. In, in this run, I use fast deployment, setting for quick compound queens, and the next supporting phone data train for the thing. We example at its several models and metrics. On campaign, 6 models, linear regression, range, decision tree, random forest, XGBoost, and light JVM. I use these mean metrics, RMSE, MAE, R-square, R-report, MAPE heavily because it can be unstable when actual sales are close to 0. So RMSE and MAE are a mean DC matrix. Now I present the key resource. The key result is rate regression is the best and most stable under walk-forward validation with feature with range keeps very strong performance while using for few features. In my resource, feature width reduces the per feature count from 30 to 7 and range still a J strong RMSE and Hey RS grade. This is important for practice because few features in the system. It is easier to maintain and explain. So if we want a reliable, simple forecasting solution, range plus feature width is a strong choice in the study. But feature width does not help every model. Here is the trade-off. Feature width help in linear models because it removes repeated and similar features. Range also handles correlate features well, so it becomes more stable. However, for some ensemble models like Random Forest, XGBoost, and LightJBM, ranging from 30 species to 7, may remove useful signals and interactions. These models often need richer features to capture complex patterns. So after feature width, some of its models can get worse. This explains as mean message feature selection is helpful for the effect on the model. Next, I focus on stability of cost faults. In forecasting, stability is critical. We need a model that works in different time periods, not only one lucky window. Across fault, range is more consistent. That supports it as more reliable choice for real deployment. Some models show bigger changes across faults, so the performance is less predictable. Finally, I conclude the study. Conclude, work forward, validation is necessary to avoid leakage and get realistic results. Range regression is the most reliable model in this study. Features with greatly reduced feature size, 30 reporting 7, while keeping range performance strong, which improve interoperability and deployment. Feature width is not always good for ensemble models because strong compression may remove useful information. Thank you for listening.